Hey guys, how's it going? Today I bring you this quick tutorial about how to add a new component to LTSpice. This works for both LTSpice 4, which a lot of people still use, and LTSpice 17. And well, if you're watching this, you probably already know that LTSpice does not include a very wide range of commonly used components. They just, for example, the 741 op amp, which is well, very popular, is not included in the default library when you download the simulator. So at some point you will find yourself needing to add a component to the library. So that's why I bring you this video. I remember when I started using the simulator, I had a hard time with this part of it, and I just wanted to, now that I understand it more clearly, I just want to hopefully make it easy for you guys to add components. For this video, I chose the TL081, which is a J-foot input op amp. And what we're going to do is, well, we have to go to the manufacturer's website and look for the PSpice model. So I already Google searched it, was the first, when I just entered TL081 PSpice model, it was the first option there. And you just need to download it. It will be a zip file. You can just go ahead and open it. And from here you will see a file. Has an odd extension 0.301, but it's basically just a netlist that we will use as a base for a component. So now you will have to extract it, and I recommend that you extract it somewhere where you know that you won't be moving or deleting the file. I recommend that you do not use just the plain desktop. It would be better if you create a folder for it, because the simulator will always look for this file when you try to use the component. So if you leave it in your desktop, you will have to leave it there for as long as you need it, and it might not be very practical. So maybe just a folder somewhere, doesn't really matter. So once you extract it, I already have it right there, you will just open the simulator and drag it to the simulator, and you will see here this is the netlist. It's just the parameters, electrical characteristics. The only thing that you need to do is go ahead and right click and create symbol. It will ask you if you want to create a generic symbol for it that has the 5 ports, and you can just click yes, and there it is. That's your file. That's it. This is your component. You can go right ahead and use it, and you will see here that this is the pinout. So if you just needed to get it right away, you can even stop here. But I will go a bit further because I just like when things look pretty. So first, you can choose particular pin and right-click it, and maybe put out. As you know, the 5 is an output, and you can do it with all the other ones. But since this is an op amp, I don't know about you guys, but seeing just a rectangle for an op amp is not something that I really like. So what we're going to do next is we're going to change this symbol, and we're going to replace it with an op amp symbol. So you will see, well, first of all, you want to go ahead and use it, you can do it so this way. You just open a new schematic, and in auto generated you will see that there is the TL081, so you can just go ahead and use it. But in this case, we're going to, as I mentioned, we're going to change the symbol. So you go to the LTSpice folder, and you will see here, well, I have it in documents, LTSpice 17 libraries sim. You will see in auto generated that the TL081 is right there. So we're going to open it. You can open it with Notepad or Notepad++ or Atom, or it doesn't really matter which text editor you use, just as you make sure that it is a text editor. And from here, now we have this open. We're going to look for a symbol that suits, that is already designed, so we don't have to do it ourselves. You can also do it, by the way, but we're just gonna go ahead and look for them a very similar component. I like using the universal op amp because it has the 5 terminals and it has the same pinout, and you will see what I mean in just a second. So here we have the symbol file, and the symbol file includes, this is the part of the sign of the symbol, all this, and then the symbol attributes. These are the electrical characteristics, and then the pinout and the position of the pins. So what we're gonna do is we're going to override or replace everything except for the symbol attributes, because we want to still keep it as TL081. So we just go ahead and with this we now copied all the design of the symbol to the TL081. But now in this case, since the pinout is exactly the same one, I'm going to go ahead and also copy this so the pinout is aligned with the model. Okay, please notice that the sim attributes remain unchanged. I did not copy any of this. Okay, so you just go ahead and save it. And then when you go back to library, sim auto-generated, you will see that the TL081 is right there, but it now has a more familiar symbol. One thing that I also like to do is we just load it as a symbol, and I do like to add a text just indicating which component we're referring to, because maybe if you have a big circuit and you just see that and you have other op amps, you won't know which one it is. So you just put TL081 and you go ahead and save it. Now in your schematic, in your symbol file, you will see that it has the pinout and the name. So well, that's it guys in regards to the symbol, and the component is now ready to be used. And just as an example of how to use it, and maybe if you're relatively new to the LTSpice simulator, I'm just going to show an example of how we can make sure that we have the right model. And the way I'm going to do it is I'm just going to go ahead and download the datasheet. And well, the datasheet will have some characteristics here that we're going to just make sure that match the symbol that we just added. So we're going to go down here, and if you see there are some graphs and the response of this particular component. And one thing that I'm going to do with it is I'm going to simulate the test circuit. So in this case, for example, it has, let's try this one. It says see figure 2, so we go down and we will see that we have a couple of test circuits. So we're gonna do the test figure number 2, and we're just gonna make sure that the response of this component is the one that the datasheet describes. And of course you do not need to do this. This is not something that is mandatory or necessary. I mean, it should work. Is TI, the one, Texas Instruments, the one that is providing this model. So it's not necessary, but we're just gonna do it again. So also, so you can see just a simulation. So we're gonna go ahead and we're gonna open a new schematic. We're gonna choose our brand new TL081. So we know that we're going to need 3 sources, and once we have the 3 sources, we will have to name them. One thing that I like to do is instead of just having a lot of wires, I'm just going to go ahead and name name the nodes so we can just link them. And the way you do that is you press F4. Let's call this B in. For now, I'm just gonna put it this name. I will rename them in a moment. Don't worry. So let's say that this is B plus. This is positive voltage, and this is the negative voltage. Just have to make sure this is the plus. We're going to name this B plus, and this automatically means that these two terminals are connected. It's like having a wire, but without the actual wire, which is pretty nice if you ask me. Next, we're going to just add the resistors as the tester describes. So it looks like we need resistor here, another resistor as feedback, load, and we also need a capacitor. Okay, we have a ground here and another ground over here. Okay, so we just wire this up. And we're gonna make sure that that response fits the graphs that the manufacturer is providing. Okay, so we have here 1K, 10K, and we're gonna do this one, so it's a 10K as well. So, oh, I forgot B in. This one goes right here. This is 1K, 10K, 10K, and 100 picofarads. Okay, there it is. So we just need to simulate it. It will ask you to set a stop time, and since we're going to, let's choose 10 volts plus and minus 10 volts plus minus 10 volts, and let's just go ahead and put a sine wave there, 1 kilohertz, and say 1.5 volt. Okay, that's our input signal. And of course, if you want to make this real, you can also put series resistance, 50 ohms, what most of the generators have. And we will make sure now that the output voltage, the peak output voltage, is around 8.5 maybe. Let's take a look. So we just simulated. Since it's a 1 kilohertz signal, 10 milliseconds should be enough. Okay, we simulated, and we see here that the maximum, this of course is saturated, the maximum voltage is about 8.4 volts. Now it says here that this should remain constant for 10K and 100K, so let's go ahead and change this to 100K. Should have the same response. And indeed, whoops, let me change that because it is pretty messy. Let's go with micro here. Okay, well maybe micro is a bit too little. 100 micros. There it is. Okay, and again we see that indeed it remained constant. We have 8.47 volts. So that is the peak voltage at 100 kilohertz. So does look like at 10 volts plus, 10 volts minus, we do have the response the manufacturer intended, or at least provided as information, and then we are modeling the right component. Since we're already here, let's just try 1 meg. And remember that when we were talking about megs, we do need to write MEG, because just an M will mean to the simulator that this is a milli. So meg, and we see that the voltage, it's about 2.49, which is, yep, pretty much what the manufacturer told us in the data sheet. So this is a successful addition to the simulator. We do have an accurate model for the TL081. You can You can do it yourself. It's pretty easy. All of this was just a plus, so you just want to make sure, again, this is not necessary, that you have the right model. Well, here it is. We have the response that the manufacturer provided, and we can just go ahead and use this model from now on. As long as you don't move the model file, you will be able to use it for as long as you please. So well, that's it, guys. I thank you for watching the video. I hope it was helpful. I hope that you learned something, and from now on, hopefully having to add a new component won't be a pain as it may have been in the past. So take care, and I'll see you later.